Hello, my name is Daniel Usma, and today I will be going over Lewis structures. What are Lewis structures? Well, Lewis structures are a diagram that show the bonding of atoms within a molecule, and if they have them, their lone pair of valence electrons in addition to that. Let's go ahead and start with what I'm going to do is I'm going to go over the rules and show you a couple examples, and at the end I will do one on my own for you to see. Let's start with acetylene, which is C2H2, and the first thing you do when you look at a compound, you draw it out, you count out their valence electrons. Carbon itself has 4, so 4 times 2 is 8, and hydrogen has 1, so 1 times 2 is 2. Add that up, it would be 10 total valence electrons. The next thing you do is you put the least electronegative atom in the center, so with the exception of hydrogen. Now hydrogen tends to be the major exception to everything that has to do with Lewis structures, but we'll go on with that when it comes to it. So the first thing you do is put carbon in the center, as you can see. Carbon, the hydrogen outside. Since carbon is less electronegative than bromide, it would also go in the center, along with carbon dioxide and methane here at the end. And then the next thing you would do is you would make sure that your Lewis structure would follow the octet rule, which is that every atom should have 8 valence electrons around it, again with the exception of hydrogen. So hydrogen only needs 2. So let's go over the examples here. There's 10 total valence electrons for acetylene, and that would make it 2, 4, 6, 8, 10. So all our valence electrons are there. Now carbon, since hydrogen doesn't follow the octet rule, carbon needs to have 8 around it. So as you can see, it's 2, 4, 6, 8 for that one, 2, 4, 6, 8 for that one. So that Lewis structure is completely satisfied. The lines are the same thing as 2 dots, which count for 2 electrons. And if they double or triple up on each other, as you see there and there, all that means is that there are there's 2 electrons, 2 electrons, 2 electrons. It's still 2 electrons. It's just prettier, I guess, more aesthetically pleasing. All right, let's go on and move to tetrabromide over here, and carbon tetrabromide, excuse me. All right, so we put our least electronegative atom in the middle, which should be carbon, connected to the 4 bromides on the outside with 2 electrons each. And then around the bromide, since they do follow the octet rule, they do need 8 valence electrons. We put 6 around them, which we put 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and with carbon 2, 4, 6, 8 to add up to a grand total of 32 valence electrons, which is what it has. All right, and then we're gonna go on and move to carbon dioxide, which has 16 valence electrons. As you can see, 2, 4, 6, 8. Remember, these each count as 2 electrons. Satisfy carbon, along with 2, 4, 6, 8. Satisfy the 2 oxygens, which would then make that a proper Lewis structure. Finally, there's methane over here, which has 8 valence electrons. Like I said before, hydrogen does not follow the octet rule, so it does not need 8, just 2. And it is seen here, 2, 4, 6, 8 for carbon, and then respectively, individually for the hydrogen, there's 2. Now I will be going over NH3. You're right behind me. All right, so we're going to draw the least electronegative atom in the middle, which would be nitrogen. And then let's draw the hydrogens on the outside of it. All right. Now we're going to go and connect them. 2, 4, 6. So I started with 8 valence electrons, just used up 6, which means I have 2 valence electrons left. All right, now hydrogen doesn't need any more electrons because it doesn't need to satisfy the octet rule, but nitrogen does. So it's connected here, so it has 2, 4, 6, and then we're going to put a lone pair of electrons up top. And that would make it satisfy the octet rule. And that is, in a nutshell, how you would draw Lewis structures. Thank you very much for watching. Please give me an A.